Boxing gloves are padded to lessen the force of a blow. A says, calculate the force exerted by a boxing glove on an opponent's face if the glove and face compress 7.50 centimeters during a blow in which the 7-kilogram arm and glove are brought to rest from an initial speed of 10 meters per second. So A says, calculate the force. So we want to know the force. Here's what we know. We know the distance of 7.50 centimeters, which equals 0.075 meters. And we know that the initial speed was 10 meters per second. What we know about work is that the net work done on something equals the net force multiplied by the displacement. We also know the net work done on something equals the change in kinetic energy. So in this case, I think it's easiest to work with this idea of kinetic energy. It just is a little more efficient because we don't have to go backwards and find the net force and then plug that in. So in this case, the net work equals the kinetic energy final minus the kinetic energy initial. But the glove is brought to rest, so the kinetic energy final goes to 0. So the net work then is equal to the negative kinetic energy. Kinetic energy is equal to 1/2 mass times velocity squared. So the net work is going to be equal to 1/2 times 7 kilograms multiplied by 10.0 meters per second squared. So the net work in this case is going to be equal to 350 joules. Now I can take this piece and plug that back into my work equation. So the net work equals 350 joules equals force times distance, which is 0.075 meters. So when I do my math here, I get the net force equal to 4,667 newtons. Now, the glove and the face compress, so over here I dropped out my negative sign, but really my negative sign never goes away because the force then would be in the direction opposite the direction of motion. So technically speaking, I suppose our net force then should also be negative. We do part B essentially the same way, just our distance is a little different. But we could shorten this up a little bit. We could say that our net force times our distance equals our change in kinetic energy. So then our net force times our 0.02 meters equals 1/2 mass, which is 7.00 kilograms, multiplied by our initial velocity, which is still 10 meters per second squared. So if we do all of our work here, we get a net force equal to 17,500 newtons. And technically speaking, once again, we're looking at this being in the negative direction. C then asks, does it seem high enough to cause damage, even though it is lower than the force with no glove? You'd have to have some kind of a reference. But this is a significant difference in force. So there is a significant difference in force. And it's enough to cause damage, but not as much damage as just a raw fist, perhaps. That's all we're going for there.